For this problem, we need to work backwards because we're given the length is 5 pi. So we're going to plug that in here, and we'll say 5 pi is centimeters because the length is not degrees. It's a length in centimeters. And then we know the measure of the arc that we're given here is 30 degrees. So I'm going to plug that in. And now the circumference is equal to pi times diameter. So I'm going to use this. I'm going to plug this in, and we can see something nice that will happen right away. If you have pi on both sides of the equation, you can cancel it out because pi divided by pi is 1. And if I divide both sides by pi, it just goes away. So the next thing I want to do is simplify the fraction. 30 over 360. If you just do 30 over 360 on your calculator, you're going to get a nasty decimal. Instead, I want you to do the other way around and notice that it's equal to 12. But the 360 is on the bottom, so that makes this equal to exactly 1 over 12. If you have a fancy calculator like mine, you can actually tell it. If you hit the math button, and then you hit fraction, you can tell it to make it as a fraction. So maybe that's a good reason to get this calculator. So then all that's left in the equation here is d. And so to solve an equation like this, if I have a fraction here, I just want to multiply by whatever is on the denominator over to the other side. So 12 times 5 is 60. And if I do that, I'm multiplying the 12 up here, and that cancels out this denominator. And so all that's left is d equals 60. But I want the radius, and the radius is exactly half of the diameter. So we just divide by 2, and we get the radius is 30.